Okay, last section for this week is 2.6. It's on solving absolute value inequalities. So it's basically like you did in the warm-up, solving an equation. We got to split it, except now it's an inequality. So there's that one extra step. We have to decide what I told you between and or. So I'm going to start off just by showing you an example where you could use an absolute value inequality. Right? I'm not sure you have to write this part down, so just watch this part and I'll show you kind of where this could actually be used. So let's say that on a winter night, the temperature always remained within 5 degrees of zero. Okay, always was within 5 degrees of zero. What does that mean? Like the warmest it could have gotten that night is, if it was always within 5 degrees of zero. Matt? Could have gone up to +5 or -5 would have been the coldest. All right? So what that means is, look at this inequality right here. Absolute value of x is less than 5. Let's try some of those numbers that you guys just said, between -5 and 5. Let's try 3. What's the absolute value of 3? 3. And then is 3 less than or equal to 5? Yep, so that works. Let's try 1. Absolute value of 1. 1 is 1 less than or equal to 5. Okay, so that works. Let's try another temperature we could have had. We could have had 0, right? It was always within 5 degrees of 0. So again, I'm just thinking of it this way. Temperature could have been anything in there. What's the absolute value of 0? 0. Is 0 less than or equal to 5? Okay, so it still works. Let's try a negative temperature. What's a negative temperature we could have had? -2. Temperature could have been -2. What's the absolute value of -2? +2. Is 2 less than or equal to 5? Yep. So what I'm trying to show you is this inequality works perfect to describe all the different temperatures we could have had. Right? But it wouldn't work without the absolute value. We got to have the absolute value in there. All right. Any question on that example? Okay. Some of our inequalities might be a little more complicated than that. Might have like a number inside with the x. But this time we don't need the number. Okay. So that inequality describes what was going on perfect. So now just to think of it on a number line, I kind of already showed you. But we were always within 5 degrees of 0. So what's the warmest that it got?
5 degrees.
Could have hit 5. And the coldest? -5. And then we would shade everything in between. So the picture kind of looks like what we did yesterday. Is that an and or is that an or? That's an and. All right? What's up, Yusef? Oh, so that's an and problem. Okay. Watch this. That's an and. What symbol did we have in the inequality that I circled? What symbol? What symbol is in the inequality that I circled? Yeah. Less than or equal to. So we're going to see that anytime you have a less than symbol, less than is and. All right? And we'll show you a trick for how to remember that. But whenever you have a less than in your original problem, it's going to look just like an and. So when do you think I would have a greater than? What kind of word do you think we would use with greater than? Yeah? Or. And if you think of it like greater, great instead of saying greater, say greater, greater, or. So it'll kind of help you remember which one is which. Right? So that's going to be important.
I'll do this first, if you don't mind. I don't care.
Is that a question or is that what's coming?
I'm doing it. Deal with it. Get out of here. All right. So guys, on your notes again, these steps to get the absolute value inequalities by themselves, going to be pretty much the same as what we did for solving equations. All right. So you guys have in your notes, get absolute value bars by itself on one side of it, one of the signs, because the signs could be different, right? So you guys have this written down. So again, if there's any stuff outside the bars, use the opposite operation. So if you had like absolute value bars plus 3, that 5, right? I want to get the bars by themselves, so what would I do? If I want to get the bars by themselves, what would I do? To get them by themselves on one side of the sign. I'm just minus 3 on both sides. That would get the bars by themselves. If I had something like this, 5 with the bars greater than -2. Oops, watch out for that table, Mr. Ray. What would I do for this one? To get the bars by themselves with nothing attached. What would I have to do, Joe? If I want to get the bars by themselves, I have something attached to them. What would I do? Okay, so this means like 5 times the absolute value, right? I want to get rid of it, so what would I do? Divide, right? Again, I don't know if we'll run into any of these when we're doing this. We talked about this when we did absolute value equations. Again, just use the opposite operator to whatever's on that side. If it's multiple, if it shows multiplication like this, divide. If it has an add or subtract on the outside, do the opposite. All right. So that's kind of like what this says, right? So on your notes you have first, right? First, do addition or subtraction if necessary. This is if the absolute value bars are not by themselves. So sometimes you got to do a little bit of extra work to get the problem prepared so you can solve it. So make sure on your notes where it says first, next to what you want to write, do addition or subtraction if necessary. So if it's something like this, like after the absolute value bars you have a plus or a minus a number, you just want to do the opposite of that and make sure you also do it on the other side of the sign. Second, or next, do multiplication or division if necessary. So like this. So if you had like no plus or minus on the same side of the absolute value, okay, skip it. If you had, like in this case, you had it showed multiplication, you have to divide. Again, guys, I don't want you to get too wrapped up in this. I don't think we may not even come across any examples like that, but just in case you do, again, just understand the absolute value bars have to be by themselves before you can solve. All right? So now, when we did absolute value equations, right? And once we got the absolute value bars by themselves, what did we have to do? Anybody remember? We had like the absolute value bars. Let's say we had like, I don't know, 2x plus 5 in the absolute value equals 3.
You guys know we did it in warm-up.
What do we have to do here? Donovan?
Subtract 5.
No, I have absolute value bars now. Chris?
Split it.
Huh? Split it, right? So what's this one going to be, Chris? The first equation I write.
It kind of looks a little weird from here, but
It says 2x plus 5 equals 3.
right. You put 2x plus 5 equals 3.
2x plus 5 equals 3. Melanie?
Is there any way you can make it bigger? I can't see it.
You don't have to write this down.
Oh.
No, I'm just showing you guys how it works. It's okay. And then over here, I'm going to have, I'll have 2x plus 5 equals what? -3. So I'm going to split it. When I did absolute value equations, we're doing inequalities now, so there's a tiny bit difference. I'm going to split it. Obviously, I'm going to write both without the absolute value bars. Once I split again, they have to be by themselves first. Here they're by themselves, I can go ahead and split it. The first one is exactly the same. What's the only difference from this one to that one? What's the only difference? Savannah? No bars. This one, there's two things that are different. What's one?
No bar.
No bars. What's the other thing that's different? Garrett?
Negative.
I made it a negative. So we're doing something along those same lines today when we do absolute value inequalities. Very simple. All right? I'm going to go. Oops. Oops. My goodness. What did I do, Mr. Hager?
What are you trying to do?
Let's try to make it like full screen.
Here.
You're the tech expert. There we go. All right. So now, on your notes, you have like this little diagram. All right. So first, in the little quotes there, for the second step, once the absolute value bars are by themselves, we're gonna split it and we're gonna flip it. This will make sense to you in a second.
Like set it and forget it.
Set it and forget it. Yes. So we're gonna split it and flip it. All right. Just like we did before, we're gonna split the absolute value inequalities, and this flip it thing, it'll make sense to you in a second. All right, but the same process we did before when we did equations. The only difference now is we're doing inequalities. There'll be one thing that's different as far as this step. So you guys have all this. All right, you guys have all this written down. Again, make sure when you split them, like it says here, it's written with no absolute value bars. So you'll have your numbers inside your bars, you'll have one of the signs, and obviously you'll have a number over here. You'll have a number there. All right? So the first one, our first inequality, or our first inequality, how are we going to write it? How are we going to write our first inequality? We're doing absolute value. Think back to how we did equations. How are we going to write it? What should it look like? Gigi?
You just write the equation without the bars.
Exactly. Like Gigi just said, right? It's going to be the original inequality. The only thing that's not going to be there, if you want to put in parentheses, the only thing that's different is there's no bars. It's the exact same information, numbers and variables that were in here, exact same sign, exact number. Nothing changes. The only thing that's different is you're writing it without the bars. All right? Now think back when we just talked about up here, right? When we do if we do absolute value equations, in the second equation, what needs to change? What needs to change? Who remembers? What happens to the number at the end?
Becomes a negative.
Good, Chris. It becomes a negative. All right? Now remember, we said that absolute value equations, once the bars are by themselves, can never equal a negative. All right? With absolute value inequalities, with the signs, it's okay if you have a negative at the end. All right? So it's okay if you have a negative number. All right? So what we're going to do here is, the only thing that's different from the equations to the inequalities, so the equations that we did like a couple weeks ago to the inequalities that we're doing now is, we have to flip the sign. All right? So whatever sign was in the original inequality, you have to flip that sign, and then the number that comes after the sign, just like you did with the equations we did a few weeks ago, you make it the opposite. Because again, in your original, you could have a negative here. You could have like x plus 3. You could have something like that. Right? It's okay when you're doing inequalities to have a negative. If this was an equals, no, it wouldn't work. Because an absolute value equation can never equal 3. But you can have an inequality sign with a negative after it. So for this one, when I flipped it, when I did my second inequality, what would this number become at the end? If I'm doing the second part, I don't worry about the sign right now, but I want to make the number after the sign opposite. So here it's negative 3. When I split it without the bars, it would be 3. Alright, so that's the only two real different things here are when you flip it, alright, obviously you have to flip the sign, and the other thing is it's okay to have a negative number after the sign. It's okay to have that. It's not like equations when it couldn't equal a negative. It's okay if you have a negative at the end. Alright? So that's the step of splitting. Now here we get into the, like Mr. Hager was talking about in the warm-up, here we get into what type of a problem is it? Is it an and or an or? That's how we figure this out. We want to talk about that right now. So, last thing, you have to graph it. In most cases, guys, we're going to tell you to graph it. If we don't, just solve it and you're done. Alright, so now we're going to graph it. So you have all this information written on here, right? What kind of a problem is it? Alright, so those two signs that are on your paper. What are these signs? What's this sign right here? Less than or equal to. Alright? If we have that, it'll become an and. So your hint, think less than. I know it sounds weird, but again, it does help sometimes. It's a less than, it's a less than. It's going to be an and problem. Alright? On your reference sheet, if you haven't looked at it yet, this is on here. There's a box with this information that you can fill in so you'll have it tomorrow. Alright, just go back in your notes, alright, from today, and it'll have all this stuff. It'll just be you guys filling in the blanks just like you are right now in your guided notes. Alright? Then we got, what's this sign? Greater than or equal to. So, what do you think what type of problem if you have that in the original sign? What's it going to become? Or, right? And like Mr. Hager said in the warm-up, it'll become a great or. Alright, a great or. So less than becomes an and, great or, the problem becomes an or. You have to go back and look at the look at the sign in the original equation. Alright, in the original equation. Now, you guys have this written on your notes as well. Remember the rules for graphing ands and ors. What are ands going to look like when you graph them? Someone tell me by raising their hand. What are ands going to look like when you graph them? Savannah? Connect the dots, right? How about ors? How do ors look, Chris?
They go in
opposite direction. Ands connect, ors opposite. Remember, this rule still applies as well. You still flip the sign if you multiply or divide by a negative number. So even like when you split it and do all that stuff, within that problem, like once you did like, say if you did like, you had something like negative 2x is in the absolute value, then we had like greater than 3, right? Again, I'll split it, it'll become 2x greater than 3. Over here, it'll be negative 2x. Flip the sign, right? So the arrow's now pointing at the negative 2x, make it a negative 3. So I flipped it once. Now, I'm dividing by negative 2, right? X, I gotta flip the sign again. I know I flipped it because that's the rule when I split absolute value equations, I have to flip the sign. But again, that rule of multiplying or dividing by a negative with an inequality, that still applies. So I have to flip it again. And then it'll be 3 over 2. All right, well, I have an example like that as well. I just want to kind of give you guys a little heads up on that. All right, so again, you may be flipping the sign twice. You may be flipping it once, because that's the rule when you split it. You may be flipping it again when you divide by a negative. So, first example. So you guys have to write this in on your notes. So you have absolute value, x minus 5, greater than 7. All right? Yusuf?
Wait, are you starting the problem yet?
Yeah, sure.
I'm
ready.
Split them apart.
I can split it, right? Why can I split it, Yusuf? Tell me why.
There's not an even number on the outside.
Yeah, there's nothing on this side outside of the absolute value that I have to get rid of. So I can just go ahead, like Yusuf said, and split it. Jake, what am I gonna write here?
X equals negative
X what?
X is negative minus 5
Yeah.
is greater than 7.
No bars, right? So I split it. Again, I didn't split it, no bars. Now, it's up to you guys. Let's split them first. This inequality is going to be what? This is one that's a little bit more tricky. What's this one going to be? Chris?
X minus 5 is less than negative.
Yeah. Flip the sign. So again, the arrow is pointing towards the 7. It's going to be pointing towards the x minus 5 now. So x minus 5 is less than
Negative 7?
negative 7. Again, split it, flip it. We split it, we had to flip the second one. Alright? Now, just like we did before. Before we even solve, let's figure out what type of problem is it going to be. What word is going to separate the two inequalities? Mary? Or. How do you know, Mary?
Because of the sign in the original part.
This sign right here. You always go back and look at this sign in the original. It's a greater, it's a great or. We'll separate it with the word or. Thinking ahead now. What's our graph going to look like if it's an or? Joel's doing it in the back. Right. Opposite directions. Or's opposite. Now, I just solved these. What's my first step going to be? Actually, this is only going to be a one. This is only going to be a one step. How do I know that's only going to be one step? What do you think? What shows me that I know it's only going to be one step? Anybody know?
Because the variables on the left side.
Because the variable's on the left side. Yusuf?
And then like you only have to like add, that's it. Like,
Yeah. How come I only have to add? How come I don't have to divide?
because it's minus 5.
Okay.
So
Gigi, what are you going to say?
There's no number.
Yeah, there's no number attached to the variable, so it's already by itself. There's nothing attached to it to divide. So it's only going to be one step. Alright? This one, so we're going to do in both inequalities. Yusuf? Plus 5. It's up to you. I'm just showing you how it works. When I do it, I like to work on one first, then do the other. But if you want to do plus 5 in both, that's fine. Alright? The 5s will cancel out. X. Nothing happens here, right? When are the two times I would flip the sign? What's one situation that would cause me to flip the sign? Savannah?
We need to divide.
When you divide by
Negative.
a negative? What's the other? Matt? Multiply by a negative. I don't have that here. It stays the same. Bring my or down. I already got my steps set over here. I didn't do anything with the x. Don't need to flip it because you guys just told me we're not multiplying or dividing by a negative. This is going to be negative 2. Ignore the signs. 7 is bigger than 5. 7 has the negative. I have to have the negative in my answer. Then 7 minus 5 is 2. That's how I did that. Now this just looks like what we did yesterday. Gigi?
We forgot to add 5 to the 7. On the first.
Oh, I didn't add it. You're right. Thanks, Gigi. Get ahead of myself. Add 5. There we go. All right. Now we got to graph it. Again, we're not looking at your knowledge of how to set up a number line. And like I said, tomorrow on the test and on your homework tonight, the number line will be numbered for you. All right. So I'm just gonna go. I'm gonna go by 2s. I'm gonna go 0. I'm gonna go negative 2. I'm gonna go 2, 4, 6, 8, 10, 12, 14. Someone help me out. Graph this first one. How about Laurel graphing this? What do I do? Just like we did last week. What number am I going to graph? What number am I going to graph? 12. What am I going to put at 12? Open circle. What way is my arrow going to go? Right or left?
Oh, right.
Yeah, so do it like this, but you can do it. Alright, open circle at 12. Going that way. How about Haley? What about this? Open or closed? Open at -2. Arrow. Again, we know we did it right because it's an or. Ors are opposite. Melanie?
Are we shading in the number line or writing it above?
Right above the number line. Remember, it's an or, right? Ors are opposite. We're only going to shade in on what?
I told them they could do it either way.
What do you want me to do?
I said they could do it either way.
Do what do you want?
They could shade on the number line, that's okay.
Oh, you got, okay.
Yeah.
You're saying go like this? Like put the thing right here and go like this?
No.
That's fine.
Either or is fine. I don't care how you do it. Again, tomorrow, sometimes we may have you on the test, you may actually have to graph them yourself, or like last academic week, you may have to pick the right graph. You know, the graphs that are on the test, I think they're actually right on the number line. So either way, I don't care how you do it, doesn't matter. Do it right on the line and do it above, doesn't matter. All right? So that's example 1A. And we're almost done. All right, 1B. This one. All right, Brady. My first equation, or my first inequality, I should say. What is it?
Will you write this down?
Huh? Yeah, write this down. Should on the back side. On the back side of your notes. So Brady, what's my first inequality gonna be?
4 minus x is greater than or equal to 2.
No bars, right? Correct. This side. How about Bethany? What about over here? 4 minus x. So you want the arrow to point towards the 2, point towards the 4 minus x. Flip it, very good. What's the number at the end? -2. Excellent. Very good. All right? So I split them, right? I kind of got ahead of myself there. How did I know I could split them? Bethany?
Because there's no.
Yeah, there's nothing on this side connected or plus or minus. Bless you.
Jeez.
All right, so again, what's my first step going to be in both inequalities? What am I trying to get by itself? The x, right? But pay attention, right? Because the sign to the left goes with the number. So what sign is with x? Negative, right? So that's gonna make a big difference when we get to the end of this problem. There's a negative x attached to both. So what am I gonna do? What's my first step in both? Yusuf? -4 in both. Again, I like to do it in both so I know I don't make a mistake. I'm minusing 4 here. That means I got a -4 over here. These are just gonna cancel out, right? Bring the negative x down. No flip of the sign, right? I'm not multiplying and dividing by a negative. I'm not flipping the sign. 2 minus 4. -2. Ellie, how about -2 minus 4?
Would it be 6?
Positive or negative?
Positive.
We're not multiplying and dividing.
-6.
Remember, if they're both negative, keep the sign, add them together. Bring the sign down, bring the negative x down. All right. My question is now, is x by itself?
Yes.
How many people say yes? Nobody. Okay. Why is x not by itself? Matt?
There's a -1.
There's a negative, even though it's not written there, there is a -1 there. So what do I have to do, Matt? Divide by what number? Divide by -1 on both sides. Anything else I need to do?
Flip this symbol.
Flip the sign, right? So here, this becomes x. Flip the symbol. Was it greater than or equal to? It becomes a less than or equal to. -2, -1. What's it become? It's positive 2, right? You could say, okay, it can become 2 over 1, which is 2. All right? When they're both negative, and have a 1 on the bottom, whatever number is on the top, it becomes that. This one's done. All right? Over here, same exact. Negative 1, negative 1. All right? Positive x. Flip the sign again, right? So that's what I was showing you guys when we were going over the steps. This is a double flip. I have to flip it because it's part of my steps. I have to flip it again because I divided by a negative. Allie?
So it would be greater than or equal to
Yeah.
6.
Greater than or equal to 6. Now, ignore all this other stuff. Let's go back up. Why am I saying let's go back up? Why am I going back up here for? Anybody know why? Nicole? So what am I looking at? Tell me if it's an and or an or. A symbol. What is it? Or, right? It's an or. Again, I don't care. We'll go by 2s again because they're both even numbers. 2, 4, 6, 8. We'll do negative 2 over here. Or, what's it going to look like? Ellie?
Open circles.
Okay, but what about the lines? They're going to go towards each other or opposite?
Opposite.
Or is it opposite, right? So this first one, how about Dylan? How am I going to graph this?
You would put a closed circle on 2.
Closed at 2, yeah?
Yeah.
And then make it go to the left.
Yeah, good job. How about Ryan? This one. Closed at what number? 6? On the right. Bingo. It's an or. And if you do it like Melanie said earlier, if you do it right on the line, that's fine too. Above, on the line, either way, we'll accept either one. Doesn't matter. There's no specific way to do it. That's an or. All right? So people feel good with this.
Yeah, I did.
Not bad, right? So on your notes, right, I want you guys right now to try 2A. On your own, using your notes.
We're gonna go over that, Mr. Roy.
We'll go over it together.
We'll
Yeah.
go over that. We'll give you 5 minutes.
Is that?
All right, guys. Let's take a look and see if we can solve it.
I solved it.
Okay. What's the first thing you got to check for? Even if you don't have to do it here, make sure what? Yep.
There's no number on the outside of the
Yep. Make sure there's no numbers on the outside of the bars. I don't see any numbers, which means we are ready to split it. Can someone tell me my first inequality? Ellie?
x minus 6 is it greater than? Less than?
Yep, that's good. So x minus 6 is less than 5. How about my second inequality? Okay, one extra thing you gotta, well, 2 extra things you gotta do on this one. Yep, Gigi?
X minus 6 is greater than -5.
X minus 6 is greater than -5. Okay, so far so good. And what word should I put between them? Is this gonna be an and, or is it gonna be an or? Bethany? It's an and, less than. So I'm going to put the word and right now so I don't forget that it's an and. All right, now what are we going to do on both of these to solve them? They're both one step, same step on both parts. Do you see what we have to do, Jacob? You want to get x by itself.
Yes, add 6 on each side.
Yep, perfect. We're going to add 6 on both sides. I'm going to do it over here too. Add 6 on both sides. That's gone. X is less than how much? X is yeah, Matt?
11.
X is less than 11. And that's gone. X is, Ellie?
Greater than -1.
I fixed that with you.
Oh yeah.
All right, I told you what it's going to be.
1. So x is less than 11, but it has to be bigger than 1. So there's solve part, but it does say the graph. Okay, so we got to do that. Let's just move this up a little so we can
See both.
see both. So we could go by probably 2s again, so we have enough room on the number line. If I go by 1s, I might run out of space, I'm not sure. So I'll just go by 2s. 0, 2, 4, 6, 8, 10. Yeah, I would have run out of room by 1s, I think. All right, so what kind of circle do I need on 11? Open or closed? Chris? Open. So I'll put an open circle just in between 10 and 12. What kind of circle on 1? Nicole? Open. And it's an and, so am I going to shade between or opposite directions? Yeah. In the middle, yep. Shade between. And there's your answer. That's it. That's an
Yeah,
and.
so the only mistake I really saw when I was walking around is people confusing the and the or. Make sure you look back at the sign of the original inequality. If you're not sure, look at your chart, and it'll tell you what you have to use.
And I think we're going to do an or next, right?
I think so.
I think, okay.
I would hope so. I don't know. Maybe.
I would hope so.
Well, we did 2 ors already. You might both be ands.
Okay, it's an and. So you guys get to try another and on your own. All right, so that's 12 minus x in absolute value is less than or equal to 9. Okay, so we'll give you guys another 3 minutes to try that one. All right, so this one, another less than. How about, David, can you tell me my first inequality that I would split that into?
12 minus x
All right, 12 minus x.
is less than or equal to 9.
Yep, less than or equal to 9. So all we do is take the bars out, and that's it. How about my second inequality? What's my second one going to be? Oh,
Minus, sorry.
yep, go ahead.
12 minus x is greater than or equal to negative.
Perfect. Flip the sign, make the number negative. Now we just have to decide on the word between the two. And, or is it going to be or? Why do you say and?
Alright, so when you look at like the top part,
Yep.
it says like 12 minus x is like less than whatever.
Less than, right. So anytime you see the less than, then you know it's an and. All right, this one's not as simple as the last one. Melanie, what's my first step
But then you
on both of those?
You wanna subtract 12
Yep.
from both,
So I'm going to subtract 12,
from both sides on both equations.
and you're going to do it on both equations, or both inequalities. What? It's okay.
Okay with that?
That's fine.
Okay. This is your classroom.
Uh,
I don't think we said to you before. I just want to make sure.
I
You're not like that, though, are you?
I don't care.
It's not a bad song.
That'd be different if it was bad.
And it's popular.
9 minus 12. What is it? Negative 3. Okay, I'll come back to that one in a second. Let's do this one at the same time. Negative x. What's negative 9 minus 12? Negative 21. Now, are we done?
no,
I remember kids saying that last year.
Why aren't we done yet?
you have to divide by -1
Why?
because we don't want a negative.
Yeah, we don't want the negative in front of the x, so the way to get rid of it, divide by -1, divide by -1, divide by -1, divide by -1. Negatives are gone, negatives are gone. I get x, but now what do I want to be careful about?
Flip the sign.
Flip the sign. So x is greater than or equal to 3. and x, what's gonna be my other one?
I'll flip your sign.
Flip my sign again. Okay, that's good, and some people, usually that's what mistake people make, they forget to flip it. And negative 21 divided by negative 1. 21. Okay, so x is greater than or equal to 3, less than or equal to 21. I think I'll go by 2 1s, 2s, 3s. Let's go by 3s. So we got 0, 3, 6, 9, 12, 15, 18, 21. Alright. What kind of circle on 3?
Close.
Closed. What kind of circle on 21? Closed. They're pretty much always the same. When you do an absolute value inequality, they're either both open or they're both closed. It's not like you get one of each, because you're always looking at the original symbol. Okay? And the original symbol has equals or it doesn't. You don't have one of each. Alright, so 3, 21, and where do I shade? In between. Yep. So in between. And there's our graph. Any questions on that? That's absolute value inequalities. Okay, so we got a couple reminders about the end of the week. Okay. So test review. Okay, that's online, right?
No.
No, it's just
You'll get that today.
reference sheet. Reference sheet is online.
It's been online since, when I say?
Tuesday or
Yeah, I restarted.
Tuesday afternoon.
Okay.
Can we print them out?
Yeah, we'll give you guys, I don't think we're gonna do those practice problems.
Okay. So yeah.
We'll give you guys some time to get, if you wanna print that out, we can do that, you can start your homework. But if you pack up early, you start packing up before like 9, 11, then we're gonna make you guys do the practice problem, so don't pack up. All right?
So don't forget, when you do your reference sheet, do the reference sheet first.
Yeah, so guys, this is where we've had issues before, so look at this first bullet. You have to, the thing that's online, the thing that's on Google Classroom, you have to fill that out first. All right, Mr. Hager, you say it. Say the same thing.
Yeah, so make sure, fill the reference sheet out first.
Now we're both saying it, maybe you'll remember it, all right?
Fill the reference sheet out first.
Because you have, again, that's what people are having trouble. Laurel, listen. That's what people are having trouble. They're forgetting to put the examples on their test review. All right? You need to have both things done to get full credit for your homework tomorrow. All right? Remember, tomorrow we'll do a little warm up. We'll go over the test review like we normally do, and then we'll go over the examples and the answers off the test review. We'll start the test tomorrow. Friday we'll finish. All right? Remember, we only have a single period on Friday, 39 minutes because half day, and then that's your last test of the quarter.